Hello guys, welcome to PyMol Studio. In this tutorial, I will go over one of the hottest topic of bioinformatics, which is molecular docking using Autodock Vina. In this tutorial, I will dock one protein molecule with 5 different ligands using Autodock Vina program. This tutorial is divided into 4 different parts. The first part will consist of preparation of protein or the macromolecule that will be used for docking. The second part of this tutorial includes the ligand files that we're going to download. Then we're going to convert it and then we're going to prepare it for our docking analysis. Then in the third part, we will dock our prepared protein and prepared ligand with each other. The tutorial will be more like not single protein and single ligand docking, but single protein and multiple ligand docking. So we will go over how we can do this in this tutorial. So before starting with the tutorial, I will make here a separate folder, and if you are following along, you should make a separate folder for each docking analysis that you perform. So I will name this folder as docking dash one, and we will go into this folder. Here I will make one subfolder and name it as data. This folder will hold my macromolecule or the protein structure. Then it will also hold 5 different ligand molecules in the SDF format that we are going to obtain from PubChem database. I will make another subfolder which I will name it as scripts. This will hold the config file and the grid files and all the sub files that are going to generate that will be generated during a docking analysis. And finally I will make a subfolder which will consist of all the results or the result files that will be generated uh, after we ran the Autodock. And again, last subfolder which will be the images of the protein ligand complex that we're going to imagine or visualize in PyMon. In the data folder, we will make a new empty notepad file and name it as a readme file. So we'll go to notepad. In the data folder, I will make a readme file that will hold the information about how we prepared a protein structure. So this will hold steps for protein preparation. And we will save this as readme. This file segregation is really important as it will keep your project neat and clean, and whenever you do whatever steps in the analysis, you need to store it in such readme files. This will help you to remember what steps you have taken. And like this docking analysis is actually from my customer, which has demanded me to dock his protein with the 5 different ligands that he has provided to me. And whenever I need to import this complete analysis back to him, then he should understand what I have done. Therefore, you should maintain such readme files in your analysis. So now we are completely prepared to go further with our tutorial. Therefore, we will go to Chrome. We will open the PDB database. So PDB, and here we will search for, hit enter. This is actually an epidermal growth factor receptor which is overexpressed in cancer cells. So This 1M17 is the PDB ID. This is the protein name, epidermal growth factor receptor tyrosine kinase, and this protein structure is in complex with one inhibitor molecule. We will download this protein in a PDB format, and we'll store this PDB file in our data folder of our docking directory. Hit save. So now the protein structure is already stored in our directory. We will have a look at this protein structure. Therefore, now in order to prepare this protein, we will open the Autodoc tools. Autodoc tools. Open this. Once we open our Autodoc tools, we need to set our working directory so that it will help us save a lot of time traversing to the working directory while working or while performing Autodoc or protein or ligand preparation. So to set the working directory, we will go to file, then we'll go to preferences, and then we will select the set option. So the third option here in this dialog box under a general button is the startup directory. Here you need to provide the path to the folder that we have just created. To do this, we'll go to our data, our docking folder, then we'll go to data. Then here in this ribbon, we'll just click here. It will display the complete path of this folder. We'll copy this path and we will paste it here in the startup directory. Paste. Click on set and dismiss this dialog box. Now we will go to file, then we'll click on read molecule. You can see that the Autodoc directly opens our data folder where we have stored our protein structure. Click on this protein structure and click on open. This will load your protein structure in Autodoc. On the left hand side you can see a panel which consists of the list of molecules that are currently been loaded in Autodoc and is been visualized in a molecular viewer window, that is this black window. So you can click on this plus option and here you can see the A chain is being loaded. Again you can click on this plus option and you can see the amino acids that are present in this protein structure. At the end you can see that these are the heteroatoms below the proline residue that are present. For example, the inhibitor molecule whose code is AQ4999. This is the inhibitor molecule for analequinazole. Then we have 19 to 20 water molecules. Now we will remove the water molecules, the inhibitor molecules, and we will keep just the amino acids. Now let's begin with our protein preparation. First we'll go to edit and we'll go to bonds. Then we will build this bond by distances. This will load all the bond distances from our PDB file into the Autodoc. Next, we'll again go to edit, we'll go to atoms and we will click on assign AD4 type. Here it will add all the coordinates of the amino acids into the Autodoc tools, and these coordinates will be in the format of the Autodoc 4 type. Next, we'll again go to edit, then we will delete the water molecules that are present on our protein structure. So next, we will add charges to our protein structure. So again, we will go to edit, charges, add Coleman charges. One dialog box pops in and says that the Autodoc has added Coleman charges and now the protein has charge of minus 155.277. So click on OK. Then we will add polar hydrogens to our protein structure. These polar hydrogens will enable the protein structure to make or form bonds with the ligand molecules that will be docked in this protein structure. For that, again go to edit, go to hydrogens, click on add. The dialog box will appear, which will prompt us to add all hydrogen molecules or the polar hydrogen molecules only. For that, we'll click on just polar hydrogens, click on OK. This will add polar hydrogens to our protein structure. Finally, we need to remove our inhibitor molecule that is present as a heteroatom in our protein structure. For that, we will go to the left panel and go to plus option. It will highlight chain A. In this chain A, we will again click on plus option. Scroll all the way down. Here you can see the AQ999, which is the inhibitor ID that is being present in our protein structure. Click on the first circle. This will select the inhibitor molecule. In the molecule viewer window, you can see this yellow is highlighted, which represents the inhibitor molecule. We need to remove this. We have selected this molecule, then we will go to edit. We'll go to delete option, and then we will click on delete selected atoms. Click on continue. This will delete the inhibitor molecule from our protein structure. Now we have inputted the bonds, then we have built all the coordinates in the Autodoc 4 type, then we have added the charges on the protein structure as well as the polar hydrogens. Now we need to output this protein structure in the PDBQT format. Sorry, the PDBQT format is the unique Autodoc file format which consists of all the fields of the PDB file, but in addition to that fields, it will also contains the information about the charges that are being present on each atom of the protein. For that, go to grid, then click on macromolecule, then click on choose. One dialog box will appear. Click on the PDB ID, that is 1M17, select molecule. Click on OK, and with the PDB ID, add the extension PDBQT. Hit enter. This change in color represents that the PDBQT file for our protein structure has already been prepared and is stored in our data folder. We can check for that. So you can go to the properties and you can see that the file is indeed the .pdbqt file. So that's it. We have completed the first step of our docking tutorial, that is protein preparation. Now that we have completed with the protein preparation step, we will write down all these steps in a shorter format in this readme file. So we have recorded all the steps that we have performed in this protein preparation step. Then we will save this readme file. This readme file then can be referred by uh, other students or the customers and review the steps that we have taken for protein preparation, and it will be also helpful for us to reproduce the same docking analysis again by following all these steps. So that's it for this tutorial.
ठीक है भाई ओके भाई ठीक है भाई मैं चलता हूँ ओके ओके बाय ओके बाय